In this last little video, we're going to be looking at how to actually plot some of these parabolas onto a Cartesian plane or onto this XY axis here. And to start with, we're going to look at something basic like f of x equals x squared. Now, I've changed y equals x squared to f of x, and the reason that I've done that is it just makes it easier to input some of the things that I'm going to show you. Alright, so we know what the graph looks like. We know that when we plot it, it will make a parabola, and we know that that's the shape that it's going to make. And we also know that, well, we know if x is 2, the y is going to be 4. You can see it there. And that's because when you input x as a 2 into the relation, 2 squared is 4. So the input is 2, the output is 4. So I'm going to show you how to actually graph a parabola if you don't know the specific shape. We're going to start off with the basic one, f of x equals x squared, and here I'm going to have a drop down table of values. I've got x on the left and f of x on the right, or my y values, my output. Now in an earlier video I said that if you know an input, for example I put in 2, it will tell me the output, and I just have to follow the rule. So I'll use this tab here and I'll write, well, the input is 2, the rule is I have to square it, and it tells me in the bottom of the box here that it's 4. So I know that that point here is 2, 4. If I was going to put in another point, any other point, 1 for example, it would tell me 1, and I would follow the same math. I would just change the 2 to a 1, and it would plot that point for me. It would show me where that is. 1 squared is 1. And I can keep going. So 0 and then minus 1. Now just remember, when you're calculating negatives, it's important to put the negative in a bracket. So it's best to put all negatives in brackets to make calculations a bit easier. And you can see here I can just keep going. And you can see that shape starting to form, and all of those points will lie on that line. So you can just connect all the dots with that nice smooth parabolic curve. And you can do the same thing with any parabola. So I'll use the other one that we've been looking at a little bit, x squared plus x plus 2. We know that shape as well. It just moves across a little bit and it moves up a little bit. And you know that that 2, just to remind you, on the end, that constant plus 2, that tells you where it crosses the y-axis. But if I want to find out what's going on at any particular value for x, I'll use 2 again. So anytime there's an x in the relation, I'll input a 2. So it's no longer x squared, it's 2 squared. And it's no longer plus x, it's plus 2. The plus 2 on the end plus another 2. And it tells me that that point there would be at 8. So if I input 2, my output is 8, and it tells me that there, and I can make that point appear just here, 2, 8. And once again, just as before, we can just follow through that table of values. We can get a bunch of points together, and we can plot that graph. So it's just a matter of choosing a domain or choosing a specific set of values for x, and then inputting them into the equation and finding out what the output is when you input that specific value. And then you plot your curve by connecting those points.